Section 6.7 Applications involving powers and roots. Now, this section involves a lot with working with the radicals to solve, and an equation that it works a lot with is your Pythagorean theorem. There are many kinds of applied problems that involve powers and roots. Many also make use of the right triangles and the Pythagorean theorem. A squared plus b squared equals c squared. In this right triangle, the longest side is the one across from the 90-degree measure. So this one here is the longest, and this longest side is called your hypotenuse. Hypotenuse. The other two sides are called legs. Now, our equation is a squared plus b squared equals c squared. These don't matter what they are, they're just your legs. It's because we're adding, order doesn't matter. However, C must be your longest side. So that's just something to keep in mind as you're setting up and working with this equation. Example 1. A viewable image size of a widescreen computer measures 21 inches diagonally and has the width of 18.3 inches. What is the height? Okay, so I'm going to try to be artistic, though I'm not at all. And I'm going to draw what is a computer screen. Now, whenever I have a word problem, it does take me a couple of times reading it. It doesn't happen right away. So take a moment, maybe pause the video, read a couple of more times. Now, the important thing it says is that it measures 21 inches diagonally. So across is 21 inches. And it has a width of 18.3 inches. So that width of 18.3 is right here. Now we're going to use our knowledge of right triangles to make it happen. Now, it didn't really say that we're working with a right triangle, but for the most part, we can be safe to say that a computer screen is in a rectangle with 90-degree corners. So we actually have a triangle. So let me go ahead and draw this triangle out. So we have this right triangle where our hypotenuse is 21 and one of our legs is 18.3. Now our job is to find the remaining leg. What is the height? I guess I should write that 18.3 somewhere else because it's specifically asking for the height. That can be confusing. All right, now I need to write that little 90-degree mark. That's important. Let's go ahead and use our Pythagorean theorem. A squared plus b squared equals c squared. All right, now the important part is your hypotenuse. That always has to be your c. Everything else, because we're adding, isn't as important. So we have 18.3 squared plus b squared is equal to 21 squared. 18.3 squared, we're going to use our calculator and raise it to the second power. We get 334.89. Plus b squared and 21 squared. Let's use our calculator. That gives us 441. Okay, now we're left to solve for b. Let's go ahead and get b by itself. Let's subtract 334.89 to both sides. So that we're left with b squared is equal to, let's use our calculator to find out how much 441 minus 334.89 is? We get 106.11. Now, that is our answer for b squared, but we want b. Now what we'll do is we're going to undo that square by taking the square root of both sides. So that we have 106. Let's use our calculator to find out how much the square root of 106.11 is. So we take the square root of 106.11 and we get a really long repeating decimal. We get b is equal to 10.30097 083. And it probably contains a lot more. We can go ahead and round, let's say to 2 decimal places, 10.30. And that is our answer. This is a Pythagorean theorem. It's a really helpful formula. You see a lot when you continue maybe into pre-calculus, when you work with your trigonometry portion. Let's do one more. Find the length of the hypotenuse, which is the longer side across from the 90 degrees, this one right here, of this right triangle. Give the exact answer and an approximation to 3 decimal places. So we have 2 legs, one of them is 7, the other one is 4. Doesn't matter which one is A or B, but since they're both legs, we can interchange them if we like. Again, our formula is a squared plus b squared equals c squared. Our c is our unknown. All right, let's go ahead and work this out. So I have 7 squared plus 4 squared equals c squared. All right, 7 squared is 49. 4 squared is 16. And we want to find c squared. Let's go ahead and add 49 plus 16. We get 65. 65 is equal to c squared. I want to undo that square, so I take the square root of both sides. That makes that go away. So we're left with the square root of 65 is equal to c. And this is our exact answer. Now, if we want to round, we can give a decimal answer and say c is about, and we can punch that into our calculator. The square root of 65 is about 8.06. It wants us to round to 3 decimal places. So we have 8.062. And these are our 2 answers. One of them is called the exact answer, and another one is the approximation. All right, let's do example 3. Find the missing length of B in this right triangle. Give an exact answer and an approximation to 3 decimal places. Okay, so we have to use, because we have a right triangle, our Pythagorean theorem. A squared plus b squared is equal to c squared. The only one that we have to be very careful about is the hypotenuse, which is always across from 90 degrees. That's your C. Okay, so let's fill out our pieces. We have a B, so this must be our A. I have 1 squared plus b squared is equal to the square root of 11 squared. What happens with that square and square root at 11? They're opposites, right? So that we're just left with 11. Now on the other side, I'm left with 1 squared, which is just 1, plus b squared. I want to get b by itself, so I'll subtract 1 to both sides. We're left with b squared is equal to 11 minus 1, which is 10. We take the square root of both sides to undo that square. We're left with b is equal to the square root of 10. And this is one of our answers. This is your exact answer. We can also round and give an approximation. It wants 3 decimal places in our approximation. So let's use our calculator to find what is the square root of 10. We get 3.1622. So we have 3.162. These are our two answers. One's an exact answer and one is the approximation. All right, that's it for this section. 6.7 Applications involving powers and roots. Thank you.